which you can think of, if you like, as the inverse to exponentials. Okay, they undo each other. We'll make this notion more precise in just a moment. Okay, so we're looking here at our formula. Y equals log base A of x. So here we think of A is a fixed number. Okay, common choices are A equals 2, A equals 10 are sort of two of your most standard choices. And we call it the base. Okay, so why do we call it the base? Well, it's related to the base of the exponential function. Right? Again, I mentioned that logarithms and exponentials should be considered inverse functions in the following sense. Okay? So if I have y equals logarithm base A of x, typically we would actually say log base A of x. This is the same as saying that a to the y equals x. Okay, so it's just a rewriting of an exponential formula in a particular way. So let's look at an example here. 2 to the 4 is equal to 16. This is something we can compute by hand if we like. Logarithms let us write this in a different way. So here a is 2, y is 4, x is 16. So the equivalent way of writing this with a logarithm is that 4 equals log base 2 of 16. So in other words, you can think of these as a compact way of solving certain types of exponential equations. Okay, and we'll look at a few basic examples that exploit this just now. Okay, so simplify log base 10 of 100. Okay, so what does this mean? So y equals log base 10 of 100 is equivalent, under what we just saw, to saying that 10 to the y equals 100. So, what number is such that 10 to that number equals 100? Well, in this case, it might be easy to just think about it. We know that y would have to be equal to 2. 10 squared is 100. So we can summarize this and say that log base 10 of 100 is equal to 2. In some ways, log base 10 of 100 is just saying, what number do I need to raise 10 to in order to get 100? What number do I need to raise 10 to in order to get 100? Okay, in this case, it's just 2. So we can look at a related problem here, and actually involving some kind of cool tricks here, right? So we can show that 5 to the log base 5 of any number y is equal to y. Okay, and this is also equal to log base 5 of 5 to the y. In other words, log base 5 of x and 5 to the x undo each other. We'll establish this a bit more clearly in just a moment. But what this tells us is that 5 to the log base 5 of x squared is just x squared, right? The log and 5 to the x kill each other off. So I'm just left with x squared. So this is another important property of logarithms. They undo exponentials. And we'll look and see that kind of even more clearly if we look at the properties that logarithms satisfy. They're in some sense analogous to the properties that exponentials satisfy, which further reinforces the idea that they undo each other.